All right, so let's go ahead and jump into our next section. This is the penultimate section, meaning we've got one more after this, and then that's the course. Pretty awesome stuff. So I'm going to jump right into the notes here.
And I just want to point something out really quick. Pretty much the stuff that we did in the previous section in 13.3, it's pretty much the same as what we're doing in this section. It's kind of putting everything together so far that we've looked at with these trigonometric ratios. So the previous sections, they gave us an angle and a length. But in this section, it's possible that they give us two lengths and we have to figure out some angles. So that's really the only caveat on this kind of problem. You have the Pythagorean theorem, so you can find the third side if you want to, or you can just use the trig identities or the trig ratios. I personally prefer using trig ratios because it's faster, in my opinion, than even the Pythagorean theorem. But let's just jump into it. We'll take a look at a few different examples here. First off, let me get my whiteboard up. Where is it? Right there. Okay. Switch. Boom. There we go. Okay. So for this very first question, let's just go ahead and take a look at it, okay? I've got my classic triangle. Let me pull this up here. There we go. Classic triangle, my A, my B, my C. Same thing that we've looked at every single time. Here's my C, here's my A, here's my B. And so we're pretty much doing the exact same thing. We're trying to figure out our A, our B, and our C. And our A, our B, and our C, which in this case we already know is 90, okay? C is always 90 in this case, in this, so far. I don't think it will, yeah, we're not going to deal with anything that is different in this circumstance. So what's given to us here is 47.0 meters, okay? So I know the length of the hypotenuse, and now I just have to determine the lengths of the opposite side of A and the adjacent side. Actually, I need another angle. I only have one. Oh, wait, no, there was another one that was given to me. I screwed that one up. This is supposed to be 54.6. There we go. So now that I know that, I can find angle B because I can just take 90 and subtract angle A, 54.6. This is given to me. So as a result, I am going to get 35.4. Okay, 35.4 degrees. Okay, so now that I've got that, 35.4, I can use, like I said, the sine of that measurement, the angle A, to figure out that A value right there. And then I can also use cosine for the B value. Okay, so the sine, I kind of skipped this in the previous set of questions when I was working on the previous section, so I'm just going to do it really quick. Sine of A, this angle, is the A over the C. So that means that in this case, sine of 54.6 degrees is equal to, my A is in my unknown. I know what my C is, which in this case is 47.0. And if you remember, that means that A is equal to the 47.0 times sine, since this is on the top, the unknown variable, okay? So 47.0 times sine of 54.6 degrees. Oops, I guess the degree measure goes on the inside, eh? That was very Canadian sounding of me. I grew up in Buffalo, New York, so it's pretty close to Canada. So that's my excuse. Sorry. All right, 47. So you can go ahead and let me pull up the calculator. Forgot to do that. It's about time. Okay, I'm going to stop with the Canadian stuff. Let's go ahead and look at this. So what we had in this example, right? 47 times sine 54.6. 47, you can see the previous section. 47 times, what was it?
Sine 54.6. Sine 54.6. Hit enter. 38.3. Boom. So that's our A value. 38.3 meters, it looks like. My B, so I could do, to find this length, I could do the cosine. So let's do cosine of A is equal to my adjacent over my hypotenuse. So cosine of 54.6. Again, I like using the same angle because it just makes it a little bit more consistent. My B over my 47.0. So that means that in this case, B is going to equal 47.0 times cosine 54.6. So everything is pretty much exactly the same except it's cosine. So we're going to get 47 times cosine of 54.6 and 27.2. There it is. So when we're solving these triangles, we're just finding every single piece, all the missing pieces, all the legs, all the angles, everything together. Okay. So again, it's important to remember your SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The tangent is the opposite over the adjacent. So in this case, we use sine and cosine because we had the C value and we didn't have A or B. So, all right, let's go ahead and do another one. So again, a lot of these is just, it's the similar type problems that we had before. This one's going to be a little different because I'm actually given two lengths on this problem instead of an angle. So here's my A, here's my B, here's my C. So in this case, I don't have A. My B is given to me as 72.0 miles. My C is 78.0 miles. And I don't have any angle measures except for the 90 degrees, which is given. Okay. So, that being said, how do we solve these problems? Well, one thing I want to point out really quick is if you look, B over C is the same thing as cosine, right? The adjacent side of A, the cosine of A, is the same as the B value over the C value. So cosine of A is equal to B over C. Okay. So in other words, the cosine of A is equal to 72.0 over 78.0. Or, if you remember, we talked about this, my A value is going to equal the inverse cosine of 72.0 over 78. So this will actually give me the proper value. So let's go ahead and punch this in. So the inverse cosine of 72 over 78 is going to give me 22.6, and that's my angle measure for A. So A is going to equal, what was it? 22.6. 22.6 degrees. 0.6 degrees. Oh, gotta move. This overheating is driving me nuts. Okay, so now that I've got that, check this out. So we can find angle B pretty easily, right? B is just going to equal 90 minus 22.6. So in this case, I can just figure out the angle measure by doing the difference. So in this case, this is going to equal, oh, sorry, I'm looking at the wrong one. 22.6, there we go. 67.4. I was going to say that doesn't make much sense. I was looking at the next problem. Okay, so 67.4 degrees. So now we've got all of our angle measures. And now all we have to do is figure out the value for A right here, okay? So I've got my, you could use Pythagorean theorem on this. C squared is equal to A squared plus B squared, and then solve for A. I'm just going to use a trig identity or a trig ratio because personally I just think they're easier. So I know that opposite over my hypotenuse is sine, so that's the one I'm going to use. So the sine of A is going to equal my A over my C, which in this case, sine of my A value is 22.6 degrees. My A is my unknown, and my C is actually given to me. This is going to be 78.0, okay? So in other words, whoa, something happened here. There we go. A is equal to 78.0 times sine of 22.6 degrees. And this thing works out. Let's go ahead back to our calculator really quick. 78 times sine of, what was it, 22.6? 22.6. Hit enter, and we get 30. 30.0. 30.0 miles. Boom, there it is. So we rounded up to the 30. In case you're wondering, it's 29.9, but that 7 right there jumps this up to a 0, which pushes that up to 30. So that's the reason why, in case you're curious. Okay. Yeah, let's do one more, and then hopefully you'll be able to see how this all works. We've been doing a lot of these problems, so if you're stuck, again, you know, I have kind of an open door, or I guess like open email policy, so feel free to just shoot me an email if you have any questions. All right, so same situation. A, B, C, draw our triangles. C, A, B. So this is given to me at 12.00 meters. So 4 significant digits here. B, this is also given to me. 24.55 meters, and C, 27.33. Okay, so I don't have my A. Whoop, sorry, I wrote these out. Ignore that. I already know what they are, but because I've worked these out. But these that was not given to me, so we'll get the C, I promise. Okay, so on this problem, we know that the opposite and the adjacent side of A is my 12 over my 24, and that's the same as tangent. So we're going to do tangent of A. This will give us the angle measure for A. So I've got A over B, which is equal to, or I should say, let me draw an arrow instead. Tangent of A is going to equal 12.00 over 24.55. So in other words, A is equal to the inverse tangent of 12.00 over 24.55. Oh, my handwriting gets really garbage. It's getting bad. Let's just finish this right up. So inverse tangent, 12 divided by 24.55. 26.05. So A is equal to 26.05 degrees. And now that I found that angle measure, I can find B by subtracting it from 90. So B is 90 minus 26.05. 90 minus 26.05. 63.95 is going to be that guy. Yikes. Readjust. 63.95 degrees. And now I need to find my value for C. So, again, you could use Pythagorean theorem if you want. I just like the trig stuff, honestly. I prefer using trig ratios. I personally think they're easier just to enter in. You don't have to worry about taking square roots and all that junk. So let's just do another trig ratio. So C is the hypotenuse, and so we'll put that as, you can use sine or cosine. I'm going to do sine, actually. I like sine. Sine of 26.05 degrees is equal to my A, which is 12.00 over my C value. So remember, if this is in the denominator, I flip. So C is going to equal 12.00 over sine 26.05. So C in this case, 12 divided by sine of 26.05. 27.33. Go away. 27.33. 27.33 meters. And one thing you should do too is you should just double check yourself to see if your answers actually make sense. The hypotenuse should always be the longest side of your triangle, okay? So if you get a C value that's actually shorter than either A or B, then you made a mistake somewhere, okay? So if you look back at all these examples that we did, do you notice how C is the longest one every single time? That should be the case, okay? If that's not the case, you probably made a mistake somewhere. So just be aware of that. One little fact, and you should be in good shape. But this is kind of like combining, this section is really just combining all the stuff that we've done pretty much from 13.1 all the way through until 13.3, like the previous sections. It's just kind of putting and meshing it all together. The next section is our final section. We're really just going to be looking at examples, like how does this actually play, or how does it actually work in the real world. There's tons of examples of trig ratios being used in a lot of different circumstances. And so I'm going to leave it there for now, but if you have any questions, feel free to let me know, and I will be seeing you next time.